This screencast illustrates in Excel the technique of using chi-squared for a test of independence between two categorical variables. In the data set we've got perhaps a result of a survey which is gender, male and female, and preference for beer. So the null hypothesis would be that there is no relationship between gender and choice of beer. So we have a large number of observations, and that obviously it's not possible just to see by eye. So we need to first of all create a contingency table or a pivot table in Excel. So the data set here, is the data correct? Yes, from A1, top left hand corner, to C151 in bottom right hand corner. And we put it on a new worksheet so it doesn't clutter up. Go OK. Now here we have the request for a pivot table, the data to add. So we'll put the preference in the column. We'll put gender in the rows, although it doesn't matter at all. The same results, whatever you do. It's just a test of relationship between column and row. So whatever it is, column and row is irrelevant. We need some data, so the individual goes into values. And you can see here some sort of a table originating, but the numbers are very high. This is because we've summed them, and actually we want to change the value field settings so that instead of sum we put count. Now we have something looking. Let's clear up the table a bit and make it larger. I'll move this across so that the table is clearer. So now we have a contingency table which we can work with. The next thing to do is to calculate the expected values, which looks a bit messy, and then we can make Excel do a chi-squared test for us. So the expected value, we do it cell by cell. So the first one to do will be the intersection of dark and female, and it's going to look a little bit peculiar with lots of different things. But what we're going to do is column total here times row total divided by n. So 14 is the expected value. Let's do the same for the male. So again, equal column total times row total divided by n. And I'm going to just quickly motor through these other ones. Now we're down to the intersection of male and light. Now we move across to the regular beers. It's exactly the same thing. So now we have our table of expected values, which we are now going to compare with the observed values from before. So we enter the formula into Excel, which equal chi-test. Now we need two sets of values. First of all, we put in the observed values. The top left-hand corner is B5, colon to the bottom right-hand, which is D6, comma. Now the expected values, so the first one is B9, colon, the last one, D10, and then we press enter. And this is our p-value. P equals 0.468. So if we set an alpha of 0.05, P is smaller than 0.05, therefore we would reject the null hypothesis. HO was that there is no relationship between gender and type of beer chosen. HA must therefore be the logical negation, which is that there is a relationship. So our results would say that there is a relationship between gender and type of beer chosen. Notice it's not more informative than this. It doesn't say whether males prefer different type, what type of beer, etc. It just shows that there is no relationship between the two genders and type of beer chosen.